So I used to post everything to the website, but now, because I have to use Canvas because of the mastering grading stuff, so it's gonna be difficult for me to manage two sites at the same time. I usually just manage everything on my website. My name is Ian Lee, Y-I-Y-A-N. So start with two letters, Y-I, pronounced as E, not Y. So E, my domain name is just the E-Electronics, Y-I, electronics.com. I pay $300 for that domain name every year. electronics.com, domain name. I'm gonna sell it for $1 million later if someone want to buy it anyway. I have, for this college, I had all the courses listed on the main page for students to access, but also in the teaching tab as well. But you don't have to get into that tab. Just look at the main page. And I have to remove this 281 class link because I probably won't be able to use it. I already planned, I have taught this class for millions of times. This time to do everything new. It's a lot of extra load for me. So I was looking at the mastering engineering problems. It's pretty easy for me, but I still have to go through every single problem in order to teach it in the class to prepare you guys for the homework assignments and exams, right? I don't want to just teach whatever I have taught. Then when you start working on the problems, they are totally different stuff, right? So I have to do that so you guys are prepared for the exams, for the homework assignments, okay? So whatever I already put in here in the summer will not be used. I'm gonna delete that page. See where I put the link over here, homework 1. That's my homework assignments I used. But anyway, I'm not going to use it. So I'm gonna delete that link. But anyway, if you are interested in what I have been doing, I'm teaching other two classes. One is the PCB design. If you are interested in PCB design, you can get into the link and look at the lectures and consider taking that class in the future, hopefully. And there's the embedded system class teaching how to use microcontrollers. I'm going to use that link because it's not going to be totally on Canvas. However, this class will be 100% Canvas. Okay? And if you register it over here, hopefully you will be able to get to this point. And if you click, for example, you are seeing whatever I'm seeing here. I'm trying my best. I've never used this before, okay? Hopefully you can get through that. You'll probably have more experience than me. And click all assignments. And you'll see several assignments already due this Wednesday and Friday. How's the pressure level? Nothing? You guys are students in mines. So it's nothing for you guys. Wednesday, I think that's just a one intro to mastering to let you know how to use it, I believe. Another one's on Friday. Is that Friday? Yeah, Friday, 23rd, right? Oh, actually Friday, not Wednesday. So 2 on Friday and 1 on Monday. 26th is Monday. Okay, 28th is Wednesday next week. So you'll have the homework 0 and tutorial 1 due Friday this week, and homework 1 due Monday next week, and tutorial 2 due Wednesday next week. So I have gone through tutorial 1, homework 1 already last night, 2 hours. So I'm going to teach you these problems today. So prepare you guys for the assignments due on Friday. Okay. Now to my homework assignments, probably 10 in total, 11 for the whole semester. Not too bad. So I used to just grade all the homework assignments by myself. If I have only like 10, 15 students, I just grade it and hard copies and return it back to students 2 days later. But 100 students, it's impossible, right? So that's probably why the department decided to do that. And there are 3 sections, I think. So totally like 300 students. And there are only 2 TAs. 5 hours for each for the TA to do all the grading and office hours. And I have tried to grade 100 homework assignments. It takes me like 7 hours just grading everything and put it all the scores to the grade book. So it's impossible. it come to minds. This is you have to deal with, right? So it's going to be master engineering, and everything will be graded automatically by the software. Okay. All right. Okay, let's talk about voltage and currents. So you are here because you have taken physics, and this is a really fascinating field. How many of you are electrical engineers? Raise your hand. None. Okay, so all of you guys are.
282 is the E circuits.
Yeah, it's for non-majors, right? Okay, cool. But no matter what, you have to learn electrical engineering. You know, it's just everywhere. So, for example, you know, I have probably fixed almost everything in my house. The fridge, the dryer, the AC, and everything. If I don't understand electricity, I won't be able to fix them. And now I got my RV towed to the RV village. I have to fix, you know, bunch of things every week. Just so many things are getting broken very easily. So you have to understand what's going on, what is voltage and currents, to be comfortable with dealing with all the electrical components, right? And other things are even more excited because, you know, the CHIPS Act, you guys probably have never heard about that. The president signed a bill 2 years ago, I think, for $200 billion. You didn't hear it wrong. 200 billion US dollars for the next 10, 15 years. It's called the CHIPS Act, CHIPS and Science Act, to counter the competition from China because of the chips industry in China has been growing so fast, right? So we want to bring the industry back to the US, getting people knowing how to design integrated circuits. This is what I'm doing at Forest College. So we acquired a server, allowing students to, you know, design and manufacture integrated circuits with a Taiwan semiconductor manufacturer, which is called TSMC. It's a 180 nanometer technology. But however, all these exciting projects starting from Circuit 1. So this class is called Circuit 1. You have to learn Circuit 1 first, and then move towards embedded systems, digital logic, integrated circuit design if you are interested in this field in the future. If you are not interested in the future, or you are from a different major, so it's all fine. But you still have to learn Circuit 1 and probably analog and digital. Because all the electrical components or appliances are just everywhere in your everyday life. So what is a voltage? So the textbook is the new textbook uses energy, which is E, divided by Q, for voltage. It's the energy to separate two charges. And then it's going to create an electric field. I'm using E in both places. I actually use V. So it's generating an electric field, which is a potential difference as a voltage. Okay? So that's the electric voltage. So very simple question, or it's an interesting comment here to let you guys know, is minus 20,000 volts a big voltage or small voltage? It's very small voltage or very big voltage? So for example, this is this is Dr. Lee, okay? And I'm grabbing a wire which has minus 20k volts over here, and I'm grounding the other hand. Is that dangerous? Yes, it's a huge voltage difference. It's going to drive electrical current from where to where? Through my body. From where to where? Hand to hand, yes, I don't have two hands, but which direction? From positive to negative, right? So this is ground. So what's the voltage for ground? It's very confusing because a lot of times we are talking about ground, right? So is the ground different? Is there any difference with the ground over here? Usually they have a huge metal plate buried into underneath the building as a ground plate, right? Is that ground different from the ground we are talking about on the circuit? Usually they are different. Okay? So the ground over here is for some accident, right? If there's any accident, it's gonna get all the current going to the reference, so you are not getting shocked. However, this ground we are talking about a lot of times on the circuit board, for example, a battery is driving a motor here. So you are building a little motor or a robot car on the circuit board, just put on the table, okay? And we're also talking about the negative reference, 0 volts here is called ground as well. You will see this a lot. It's labeled as GND, ground, it's 0 volts. So this ground is definitely different from the ground over there. Since we just put the circuit board on the table, there's nothing connected to the ground over there, okay? We don't have to worry about that right now, it's okay. After you have dealing with all the circuit stuff, you will be able to understand. But now let's just think about, just remember that the ground we are talking about in the circuit or here in this class for the first like 10, 20 chapters, it's just a 0 voltage reference. It's just a 0 voltage reference. If I'm talking about, if I draw a little triangle here or something like this, okay, like this, what's the voltage here? What's the voltage? It's just 0 volts. Okay, remember that. I'm going to talk about this times and times in the future, okay? So this is just a 0 volts, nothing else, just 0 volts. So if I'm driving a motor here, it's gonna, if I have a voltage difference, it's gonna flow current through the motor and run it. That's it, okay? It's gonna be a floating, it's called floating ground. It's on the table, it's not physically shorted to anywhere else, it's just on the table, okay? We build the circuits on the breadboard. So now let's come back to this point. This is super dangerous because 0 volts compared to negative 20 kV, this is positive. Even though it's just 0 volts, it's still positive. So the current is gonna flow into which direction? Positive to negative, right? It's gonna go that way. It also depends, another note here. I mean, a lot of times when we are talking about 20 kV sounds like super dangerous, right? It also depends on what? Current, yeah, or power, right? Because power equals VI. All right? Sometimes you can build a voltage booster or a high voltage generator and you can generate 20 kV on a little tiny circuit. I've done that so many times. And you touch it, it's fine. Why? I'm just driving that using USB sometimes. I can use 5 volts DC voltage and I can build a circuit to step this up to 20 kV. It's not difficult to build. It's called a voltage multiplier. You can build it and boost this voltage to 20 kV. And your 5 volts is usually from where? Anybody know that? Yeah, power, sometimes we talk about 5 volts, usually like USB, right? USB is 5 volts, always. If it's USB, 5 volts, okay? And some of the components, for example, the microcontrollers are only taking 3.3 volts, like the, not Arduino, but the ESP32s, or other devices, only taking 3.3 volts. 5 volts is gonna blow it up. So 3.3 volts, but we're still using USB to power it up. But it's fine because we have voltage regulators to step it down to 0.3 volts, so that's okay. Okay? Anyway, so we can use USB, like USB cables, and 5 volts and boost it to 20 kV. If I touch it, it's gonna be fine. Sometimes I won't be able to even feel it. But here, let's assume this is from the power plant. Infinite power, okay? So this person is gonna be killed. Let's don't say this is me. Okay, someone will be killed, right? Easily. So if I, ideally, okay, theoretically, I can grab 2 points. They are both minus 20 kV. Okay, I can grab it at the same time, theoretically. Exactly same time. Am I going to be fine? Why?
There's no difference.
No current, no potential difference, right? So there's no potential difference to drive the current from one end to the other. Okay, no current. So if I'm talking about that in that way, minus 20 kV is a pretty high voltage. So when we are talking about voltage, it's actually the amplitude of the voltage, not the, don't consider the sign here. The sign is only going to determine the direction of the current flow. Okay? So if you see problems in master engineering assignments, you'll see problem like that. It's, for example, it's giving you a energy, it's being used. You know, to be honest, I rarely use energy and charges in my circuit design problems usually. But this is just to let you know how the voltage is being defined. Okay, only happening for the tutorial 1 or homework assignment 1. For the following homework assignments, we're probably not dealing with energy for a while. Okay. So energy, the units is in joules. Okay, and charges is in coulombs. Coulombs, and V is in voltage or volts. So if you see problems giving you this one, you should be able to know how to calculate, right? How to calculate E given V and Q, how to calculate V given E and Q, so on and so forth. Easy problem, okay? Another thing you'll see in tutorial 1, which is due Friday, is the direction of the voltages. So if I draw a battery, this is like a double-A battery here. If it's labeled as 1.5 volts, this is the symbol of the battery, usually in circuit simulators. If I put a 1.5 volts here as plus minus, all the voltages are just a relative from one point to another point. Okay, so 1.5 volts, if I label plus minus like that, it's a voltage from where to where, or the voltage difference from where to where. Plus to minus. So I'm doing a subtraction from here to here, okay? So if I ground this point, what's the voltage at this point? If I ground here, it's gonna be 0 volts, right? If I, ground, like what I said at the very beginning of the class. Ground is 0 volts. It's 1.5, yes. So how to do that? It's 0 volts. And this battery, if I'm telling you this is the battery has 1.5 voltage ratings, it's gonna boost. It's gonna boost the voltage from here to here, from minus to plus. This is how you remodel your mind as an electrical engineer in this class. Okay, so 1.5 volts is gonna boost voltage from here to here. Since we know this is 0 volts, so this point will be 1.5 volts. So if I connect another circuit like this, if I ground here, that's 1.5 volts, 1.5 volts. So what's the voltage here? What's the voltage here? This has been used in many different places, especially for some of the lectures later this term. For due power supply for the op-amps amplifiers, where we have to use the plus minus voltage supplies later.
It's 0, right?
Yes. Where is 0?
The 2 arrows that you drew at the bottom.
What is this symbol? Like I thought. This is ground. So here's 0, right? In the middle is 0 volts.
Should the 2 arrows be negative 1.5 each?
Let's start from 0 volts first. Okay? Someone else raise your hand. Right. So don't get confused. The arrows are not. Sometimes you'll see this symbol in circuit design simulators. This is usually a VDD or VCC. That's a power supply. Okay? And if you see this or this, these are grounds. That's power. Oh. This is power, this is ground. So I'm just pointing to this point here because it's 0 volts.
Is it 3? 1.5. Or not 1.5.
But they're different. They are different. They will be different. Oh, they'll be the same. Sorry, they'll be the same. Is this allowed? Is this allowed? I'm grounding the anode of the battery. Why not? It's just grounded. Just grounded. So 0 volts, like what I said, use the same model like I just told you guys. Okay, remember. Have to remodel everything compared to physics 2 or any physics class you have taken. So from here, we know the battery has energy inside, right? So it's gonna boost the voltage from one side to the other. It's gonna boost the voltage from one side to the other, okay? So if here is 0 volts, it's gonna boost it by 1.5 volts, so we're getting 1.5 volts on the other side, okay? If we ground the anode, it's gonna step it down by 1.5 volts. It's a voltage rating by the battery. No one can change it. Okay, it's going to step it down by 1.5 volts. So it's going to be 0 minus 1.5 volts for the cathode. So what's the voltage at this point? Here. Same, right? I didn't draw it right, but anyway, it's a good example. What about this one? Still ground in the middle. I like it because it's going to confuse you.
Ground 0 volts.
Yes. Got it. What are the voltages here?
Negative 1.5 on the left.
No, I didn't tell you it's 1.5 volts battery.
Oh.
I'm just kidding. Yeah. So what's the voltage here?
Negative 1.5.
Yes. Here. Yes.
So the triangle floating ground doesn't correspond to any physical object. It's just a convention for specifying the absolute voltages.
It's a reference. It's not a physical component on the circuit, which is to short all the cathode of the circuits into one point. So we consider that one as a 0 volts reference. It's still confusing, right?
So it wouldn't make sense to also connect the thing on the other side of the battery to a different triangle.
If I do that,
Yeah,
then you are not able to deliver any energy to anywhere, and it's going to burn the battery. Why? So what the triangle means? So as an electrical engineer, when you are looking at the schematic, you should know that whenever I have, how many grounds on the circuit? Usually, just one ground. So which means all the triangles are what? All the triangles are shorted. It's just one node. So I didn't draw it, but actually they are. If I draw a triangle here, what that means? They are connected, right? You got plate that, right? You got a battery, you short the two terminals, what's gonna happen? It's gonna burn. But when you're camping, it's fine since you can start a fire using that, right? Does that make sense? You got two ground triangles that are actually shorted, even though I didn't draw it. But in the future, you should know that they are shorted together.
so all the voltages are basically relative, and we have the triangle that represents 0 volts.
Yes.
And we just choose the triangle with 0 volts because that's convenient for doing math and stuff. We could say
Yes.
the triangle represents 10,000 volts. And
If you compare to negative 10,000 volts, right?
Yeah.
Yeah.
Okay.
Yeah. So why? Let's just think about real circuits. There is no physical part which is called ground. It's not a piece of thing on the circuit board. Okay. So if you grab a battery, it's plus minus, right? And we are trying to connect it to the resistor and the motor to spin the motor like that. We just build a circuit like that. But you can see a lot of examples like this in this class because they didn't draw any triangles or they didn't draw any grounds. But whenever you get into the lab, you have to deal with grounds. Anyway, just let you guys know, a lot of textbooks they don't draw the triangle here, which is not right. But just probably doesn't want to confuse students like what I'm doing here. But anyway, you should know that we usually ground the cathode of the power supply. We just draw it, right? It's not a physical thing on the board, but we treat it as 0 volts. So still confusing why we know and how we know it's 0 volts. It all depends on how you measure it. If you grab a multimeter, so the multimeter usually has two probes, right? A black and red node, a black and red probe, like that. Okay? If you get a black probe to the cathode of the battery, and you have the red probe you push it against the cathode as an anode of the battery. So you are reading what? What? Yeah, across the voltage rating of the battery, which is 1.5 volts, right? Okay, so we are just treating this guy as a ground or 0 volts. It's not a physical part on the circuit. So it's just not a motor, but there are so many other components. They need a reference voltage. For example, a transistor or a chip, like say just a chip. Integrated circuits has a plus minus power supply on the chip. So you always want to ground the minus pin of the integrated circuits to the ground, and the positive to the power supply. Actually here, sorry, to the power supply, not here. So all the circuits, they have the same base or same baseline. So what I mean that is you have 1.5 volts from here to here, okay? And that 1.5 volts will be treated as 1.5 volts for the chip as well, because they share the same cathode. So they share the same baseline. So whenever it step up to 1.5 volts, they know each other are taking 1.5 volts at the same time because they have the same baseline. So that's the meaning of ground. It's the baseline or 0 volts of the whole circuit. All right, still confusing, but you guys will get it later. Okay, that's one of the problems you need to know. Another thing you want to have to talk about is polarities of the voltages. So for example, we have a battery, again, 1.5 volts, and I have a multimeter. I should brought my multimeter, but I didn't. If I probe like that, I'm going to read 1.5 volts. If I probe like this, I'm going to read negative 1.5 volts. Okay, you need to know that. And whenever you see a problem in their master engineering, if they label a component, they didn't even draw whatever is in there, just a box, okay? If they label it as plus minus, they're talking about the voltage of this voltage drop across this component, for example, 5 volts. So that's the voltage from here to here, okay? If this is A, this is B. That's VAB, or VA minus VB. Is that clear? If I still draw a minus plus like that, if I'm telling you this is the minus volts drop from A to B, what's the real polarity of the component, or the voltage across the component? So it's minus volts from A to B. Just flip it. So it's going to be 5 volts. So VBA will be 5 volts, right? So that's a real voltage drop, physically. But you can label it anyway. As an electrical engineer, you can label it anyway and calculate the current. It doesn't matter, it's just vectors. If the voltage drop, anybody familiar with the voltage drop stuff? Like when I'm talking about voltage drops, what does that mean? Ohm's law, right? You learn Ohm's law in physics. Okay, what is Ohm's law? Just tell me in a very straightforward way. If you are in an interview, even though you guys are not electrical engineers, but if they ask you what is Ohm's law, V equals IR, but that's the first level of answering that question. But what else? That's good. That's correct, actually. What's really happening? Keep that in mind in the future. Keep that in mind. It's super helpful.
Is it the voltage drop across the resistor?
Yes. When you run a what? Current through the resistor. Okay? Could you guys seal this in your mind? It's going to be super helpful. Okay? Ohm's law. All right? You run a current through a resistor. You got a voltage drop. That's it. current, voltage drop. Okay? So we can, if the problem ask you, or whatever given by the problem is like minus 5 volts from here to here, you should know that it's physically in the circuit, it's a voltage drop from B to A. Okay, it's not A to B. From A to B, it's dropping negative 5 volts. Let's don't think about that way. It's confusing. Like dropping a negative number. Why do we have to do that? Right? So dropping a negative number is actually dropping a positive number the other way. So if they tell you this is plus minus and negative 5 volts, you just flip it. So you'll know that it's plus minus and 5 volts and plus 5 volts. That's a physical voltage drop across the component. And also if this is labeled here as like a current here, that way, if it's telling you this is 1 amp, it's telling you that's 1 amp, what's really happening? It is 1 amp. It is 1 amp from left to right. Okay? If it's telling you this is minus 1 amp, what's going to happen? What's happening here physically? It's right to left. Okay, so if I'm telling you, just redraw it, okay? Here's a component, plus minus negative 5 volts, and current that way, negative 1 amp. Could you convert it to the version that describes what's really happening on the circuit, in the circuit? What's really happening? Switch that, right? So it's going to be plus minus 5 volts. Okay, let's make it right. And the current flowing that way, 1 amp. So in that way, you will be able to know if the component, whatever the component is, right? It's a black box. You'll know that, is it absorbing energy or delivering energy? So whenever it's delivering current out from anode, it's delivering energy from the outside of the circuit, to the outside of the circuit, sorry. If it's getting current flowing into the anode, it's absorbing. So think about the battery. Think about a battery, okay, plus minus. If this battery is flowing a current out, so this guy is delivering or absorbing. Delivering because sending current out. Okay? If the current is going inside, it's absorbing. How could that happen? Charging a battery, yes. Or anytime you have a higher voltage outside compared to 1.5 volts, if you have like 3 volts here, for some reason you have to connect it that way. So you got a higher voltage, lower voltage. What's going to happen is going to flow current into the battery. So this battery is going to absorb energy from this battery. Okay? So whenever you see a problem like that, and you want to determine if the component is absorbing or delivering energy, you want to convert it to the physical, to the real situation first. And then it's going to be easy to determine that. Make sense? Okay. Do you know that? Any questions so far? So let me try one really quick example with the simulator. I don't know if you guys are asked to use LT-SPICE or any simulators in the future, but just let you guys know something exists. So if I'm grabbing a power supply, ground, and 1.5 volts battery, and I'm going to draw a wire. here. If I run, if I run a time domain analysis for 1 second, for example, and I run it, and I'm able to probe this point, I will see 1.5 volts, right? This is free, like only 5 megabytes, I know, probably 10 megabytes or something. You can download it. It's called LT Spice. So you can, whenever you are seeing problems with the circuits, just feel free to simulate it. Not letting you guys know how to cheat, you know.
Can you say the name of that again?
LT means linear technology. LT Spice, SPICE, Spice. So it's being used in the kitchen. Oh, link to the canvas? I don't have that yet, but I can. Yeah, I can do that. Yeah. Hmm?
It's not linked, but it is listed on
Okay, cool. Yeah, I'll do that. Okay. LT Spice. Spice means it's a software. It's a simulation program, as integrated circuit simulation emphasis or something. I got a quiz in my graduate school. That's why I know the full name. Ridiculous. You guys need a quiz like that as well?
What's this running off Ansys? It's running off the Ansys electrical package.
No, it's I think it's do you know Linear Technology, which is a very big company making all the integrated circuits? So I think a team of the big company just designed the software for circuit simulations for free. I've used this daily, and it's very useful. So you can probe here, right? The probe here is compared to ground is 1.5 volts, and I can drag it. Let me see. Where's the little hand tool? Probably this guy. Oh no, it's duplicating. So they recently modified the version. So I see. Probably this guy is trying to drag it. Okay, I can drag it. So if I have another power supply, let me drag it further, so I have the room for it. I put it here, okay? And I got another 1.5 volts. Okay, yeah, so it's gonna be 3 volts, right? If I rerun it, it's gonna be 3 volts. It's two batteries in series, giving you a higher voltage, so you can power up a bigger, appliance or electronic component device at home. And so, what's the voltage here? Still 1.5. It's not changing, right? Yeah, still 1.5. So, what's the voltage? So, if I ground it, let me see. Just some weird circuit here. If I ground this point. So what's the voltage here? 1.5, yeah. What's the voltage here? 0, still 0. So I'm actually shorting these two terminals of the battery. So what's gonna happen? It's gonna burn which one? Burn the lower one, right? Yeah, that's not good. So if I ground the top, if I ground the top, what's gonna happen? It's gonna burn both, right?
Would that just be the same as connecting both with a wire?
Connect both what?
If you connect both with a wire, would that just be?
Yes, yeah, it's like same thing as you connect the anode cathode of the one single battery. Just two batteries, you can treat it as one single 3 volts battery, right? So they're shorting the anode to cathode.
What would be the voltage in between the two?
In between, it's gonna be because the circuit itself is not right, so it's gonna drain the current. It's gonna drain the battery very quickly, so it's not a valid circuit. It's changing over time actually. You know, if you are draining a battery, the voltage of the battery will change, right? It's rated as 1.5 volts, but you are draining that really quickly, you are getting probably anything below like 1 volt very quickly. So it's changing. So I'm gonna delete here. All right. If I run it, This circuit is fine. Okay, it's allowed or it's permitted. It's okay. So what's the voltage here in the middle? Negative 1.5. What's the voltage here? Negative 3. Let's probe it. Negative 1.5 and negative 3. Okay? What's the current?
There's no resistor associated with it.
Is this a closed circuit? I didn't close it. Is there any current? No. Okay. So current is? Oh, no current. So current is 0. Okay? This brings up another really good example for you guys to think about. .5 volts resistor. Okay. What's the voltage here? So I always talk about the voltage is relative, right? So it's like different potential difference from one point to another point. So why I'm also saying what's the voltage here as a point? It's 1.5, but why I could also say what's the voltage here, like a node, like a point, because voltage is always a different voltage difference, right? It should be the difference between two nodes.
It only makes sense because you have a grounded.
Yes, because I'm comparing that point to
0 volts.
ground, so it's gonna be this point minus 0. It's still this point, so still a voltage difference from this point to ground. So that's why I can see that. Okay, so the voltage here is 1.5 volts. So what's the voltage here though? Why?
There's no change.
No change. Yeah, both of you are right. So because there's no, I didn't close the circuit. So what's the current here? 0. And assuming this is R, doesn't matter what R is. Okay. So I times R will be 0 volts. So what is 0 volts meaning? What does that mean here? Yeah. So like I said, what is Ohm's law? Voltage drop across the resistor when you have a current flow through it. Okay? So is there a current flow through it? No. What's the voltage across it? 0. So what's the voltage drop? 0. 1.5 volts here, 1.5 volts here as well. Does that make sense? Does it matter the value of the resistor? Like 1 microohms or 1 ohm? It doesn't matter because I times R will always be 0, right? Okay. Another note I want to bring up here. When we talk about load. 50 ohm load. 1 megohm load. Which one is the big load? Why? Because it's bigger?
Yeah, assuming they're the same current, right?
Oh. But you always supply current with a voltage supplier. Yeah? So if voltage is a certain value, like 5 volts.
They're gonna be the smaller one because the current's gonna be larger.
Yes. It's 5 volts divided by 50 ohms compared to 5 volts divided by 1 megohms. This device is a lot easier to drive. That's what we say in electrical engineering. Drive. You drive the load. Which one's easier to drive? 1 megohm definitely is way easier to drive compared to 50 ohms. So the 50 ohm load are usually, you can see them from DC motors. So little DC motor drive a little robot. Okay, all these motors are usually like 50 ohms. It's a heavy load for a AA battery. So if you use like 2 AA batteries, usually have to use 3 probably. 3 AA batteries to form like a 4.5 volts to drive a little robot car with 2 DC motors. Probably cannot even run for like more than 20 minutes, 30 minutes. But I can use 2 AA batteries to generate 20k volts. Can you believe that? You can just build a voltage multiplier. with diodes and resistors. Actually, just diodes. Just diodes. To form a voltage multiplier to supply like 20 k volts. Usually, we stop at like 5 k volts. 20 k volts would be too many stages. The circuit will be big. But you can easily generate 5 k volts with 5 volts from USB. Okay? And that's one of the products that I just sold to a company. For example, I'm driving. Oh, it's just putting all the examples together. Let's take a look at it. So, for example, this one is being supplied by a USB. What's the voltage for USB? Very quick. 5 volts. Yeah. 5 volts to this voltage booster. Usually, I put an HV here. HV, high voltage. Okay. So, for example, this guy is able to supply, let's say, 5 k volts. Okay. And if I'm connecting a resistor here and a very sharp node, it's emitting ions. We don't have to know details about it. Emitting ions to the air. And this is 20 megohm. So 5 k volts here, 5 k volts here as well, because there's no closed circuit. Okay? No closed circuit. Is this a heavy load or light load? Like what we said, this will be a pretty light load. So I'm using just a general USB cable. Usually USBs are not running high current, right? You know that? Okay, so USBs are not running, usually like lower than 1 amp, I think. Is 1 amp high or low? Compared to power electronics, it's low. But actually in lower voltages stuff, like we are building here in circuit 1, is usually considered as, middle and higher end already. Like 3 amps is already the highest we are dealing with for electronics. So anyway, so this is a really low load, light load for the circuit. So it's very easy to drive. I can do the oscillations inside easily with just a 5 volts USB. It's not a problem at all. Okay, just let you guys know. So we'll cover more examples on Wednesday. So see you guys today.